In this video I will cover a realistic and advanced third-person swimming system. You can enter the water to start swimming with smooth transitions and sound effects. If you are close enough to land and there is not much water above you, the player will exit swimming smoothly. The player can use WASD to swim with animations. If swimming on the surface there will be sound effects. Holding Q and E will let you descend or ascend with player rotation. A bubbles particle effect will spawn for more realism. While underwater, there will be an ambience sound effect. There is also an advanced buoyancy setup so the player will actually move with the waves when treading on the surface. If you purchase the project files you will get an exclusive leaning system. The player will lean towards the movement direction. Rotating while swimming will look more natural with this leaning feature. This video will require the water plugin which I showed how to set up in my previous island video. If you only want to make the swimming, you can watch just the ocean parts of that video, or alternatively watch a different video on how to add water with the plugin then come back to this video. Please comment down below if you are stuck with how to set up the water prerequisites and I will help you out. First we will get the animations. I am going to use Mixamo for this, but if you have your own animation set it is better since these animations aren't that good. The first animation will be treading water. Make sure to download it without skin. For the rest, I will get the swimming animation and modify its parameters. Click in place first as we aren't using root motion for this. I will download one with the default parameters for swimming on the surface and underwater. Realistically you want a proper surface swimming animation where the player is crawling, but Mixamo didn't have that one. For swimming fast, I will change the intensity to 100. For idle underwater, I will change the overdrive to a low value to slow it down. I will also reduce the intensity and reach all the way down so there is as little motion. Next I will use this Mixamo converter tool to convert the rig from Mixamo to the Unreal Engine standard one. I will put a link to the software in the description. It also has a guide on how to import the UE5 characters to Mixamo and the whole process if you don't know how to do it. Now open Unreal Engine. I will make a new folder for the swimming assets. Import the animations. Since I downloaded variants of the same animation I will now rename them appropriately. We will now make two blend spaces so we can transition between the animations smoothly. The first one will be for surface swimming. Make a new 1D blend space as this is not a directional system. Change the axis name to speed. The maximum value will be 1 as we will normalize the speed value from 0 to 1 when setting it. We only need 2 grid divisions since there will be 3 animations to add here. Set the smoothing time to 0.2. At speed 0, add the treading water animation. Hold Shift to snap it to the grid. In the middle, add the normal swimming, and at the end at 1, add the sprint swim animation. Finally set the sample smoothing weight speed to 2 to make it transition smoothly. You can adjust these values after testing if you want. Duplicate the blend space and rename it for swimming underwater. Here I will just replace the first animation with the underwater idle. Again, if you have your own animations you can use the proper ones instead as the code will work with any. I will now get the sound effects that we will use. You can use any, but I will get them from Pixabay as it is royalty free. First will be the splash sound for entering water. Next is for when the player comes to the surface from below. Then is an underwater ambience one. Finally is a sound for when swimming on the surface and the water should splash. I have already downloaded and renamed them appropriately. Make a new folder and import them. Now we will make the enumerations. These are basically a way to keep track of a value with a name so the programmer can easily understand it. Make one called swim mode. It will have 4 values, which are treading, surface swimming, underwater idle and underwater swimming. Make one more called water interaction bone, which will have 2 values, which are hands and feet. Now make sure you have the Buoyancy plugin enabled. Next, make a new actor called Swim Buoyancy. This blueprint will be used to simulate buoyancy onto the player, since it will only work with physics objects, but the character is using character movement instead, so buoyancy won't actually make them float in the water. Add a cube to this actor and make it the parent component. Set simulate physics to true, then uncheck all visible options so it is not seen in game. Now add the buoyancy component to it and add one single pontoon. We only need one, since one is enough to gather the Z height information from it. Now in the event graph, make a custom event called set XY position. Make a new variable of type pon for the poly reference and set instance editable and expose on spawn to true so we can set it dynamically. Copy the following code. This event will, as the name suggests, set the X and Y positions of the actor as it needs to follow the player. However, we can't simply attach it to the player as the Z position needs to be independently set by the buoyancy component. I will now comment the function. Also in the cube's collision, set the preset to custom, then set everything to ignore except physics body. This ensures that the cube only interacts with the water and does not obstruct the player movement. Now duplicate the blueprint and rename it Swim Actor Enter Check. This will be used for checking when the player actually enters the water, as we can give it a custom offset to the player. Delete the custom event. Select the buoyancy component and scroll down. Add an unentered water delegate event. We will fill this event in later as we need it to use a BPI function. Now we will add a fluid simulation actor to the scene. In the content browser, click on settings, then enable show engine content and show plugin content. Search for BP_fluid sim 01. Add it to the scene, then reset its location. Scroll down and find water body. Set it as the water body ocean. Then change the following settings. These settings are changed since it didn't work otherwise with the other solver. For the simulation world size, you can set it as the extents of your ocean. If you enable Show Simulation Mesh, you should see a plane for it. You can align the fluid sim to the surface by setting the Z value of the water body, ocean and fluid sim to be the same. Now make a new blueprint interface called Water Interaction. Add two functions for start and end swimming. Then add one called Add Water Interaction with a water bone enum and float input called Bone and Size Multiplier. Finally, add one called Get Swim Variables with a boolean, swim mode enum and two float outputs with these names. I accidentally made them inputs but changed it later, so make sure you add them as outputs. Now open your character blueprint. First add a scene component to it called Swim Enter Scene. Position the Z value of this where you want swimming to start, so when the player is underwater above that point swimming will start. Make another scene for the buoyancy object and set the location to origin. Now add a buoyancy component with one pontoon at a Z location of 100 and radius of 25. I mentioned that buoyancy won't actually work on characters, but this is being used just to get water information such as depth, as we can still access it. If you want to see pontoons in game to debug, you can type the following console command after pressing the back quote key. Next, select class settings and add the water interaction BPI. I will go back and quickly change it from inputs to outputs for get swim variables. Now open the function and promote each output to a variable. Add an unentered water delegate for this buoyancy. This will be used for sound effects, so we can tell when the player submerges as opposed to just starting swimming. Play the enter water sound at the actor location. For the volume multiplier, we want to control it based on the velocity at which the player entered the water, so we can use a map range clamped using the absolute value of the Z velocity. This will normalize the velocity range we input from 0 to 1. For the pitch, we can add a random float in range for some variance. Add an on-exit water delegate and replace the sound with the exit water. You should change the min value in the map range clamp to something like 0.1 so it is still hearable at the lowest velocity range. Next, make a custom event called toggle water enter check with a boolean input called enabled. This will be used to spawn and destroy the water enter check actor as we don't need it while the player is currently swimming. Copy the following nodes. This branch checks that there is currently an enter actor by checking how many child components the scene has. Make sure to set the player ref variable from the actor to self. We will use attach actor to component to attach it to the swim enter scene. Change the location rule to snap to target so its position is set to the origin of the scene. If false, we want to destroy the actor. We can't destroy the component since it is an actor we attached, so get the owner of it then destroy actor. Next, add another custom event called toggle underwater ambience to control when it is played. Copy the following nodes for it. I will categorize F the currently made variables. This either fades the underwater ambience sound in or out using an event so it can be easily called when needed. Now go to the input actions and create a copy of IA move called IA descend ascend. Add it to the input mappings. I will use Q for descend and E for ascend, but you can use any keys such as shift and space. For the descend, add a negate modifier. Next, make a new function called swimming buoyancy with two float inputs called swimming buoyancy z correction and interp speed with default values of 50 and 10 respectively. Get the swim mode variable and add a switch on swim mode. For treading and surface swimming, add a branch since we only need to apply buoyancy when on the surface. Get the IA descent value. Make sure the value type is axis 1D as IA move was 2D and we only need one direction for this. For the branch, check if it is greater than -1. This is since we don't want to apply buoyancy when the player is trying to descend, since that way buoyancy will keep being applied, setting the player's Z location and you won't actually be able to move down. Make a swim buoyancy variable and copy the following code. This valid node ensures buoyancy is only applied if the swim buoyancy actor is spawned. For the location, we will use a vector interp to smoothly set the location, as otherwise it will snap and this will look weird if the time we set in the timer later is higher. This calculation gets the Z value of the buoyancy actor and subtracts an offset from it, which is the function's input. It is multiplied by a factor based on if moving on the surface, so we can account for the differences in the animations. I will now comment the function. Next, make a function called exit swim trace. It will have three float inputs called up offset, down offset, and max depth with default values of 25, 25 and 100 respectively. Copy the following nodes. I will make the draw debug type an input too, so I can easily debug later if needed. This trace checks if the player is next to land by checking below them. Then get the current water body components of the buoyancy component and get an array element from it with index 0. We will check if this is valid so we can see if the player is in the water. Copy these nodes. This checks if the player is close to a realistic exiting position by checking if they are close to land and there is not much water above them, meaning they aren't just at the seabed. If true, call the end swimming BPI function. Make sure to include depth here. In event begin play, call the toggle water enter check event and set enabled to true. This spawns it by default when the game starts, as the player will be on land. Now we will do the start swimming event for the BPI. First check if swimming is false, then call toggle water enter check with enabled set to false. This is since while swimming the enter check isn't needed. Then set the movement mode to flying. There is a swimming movement mode, but it didn't work as expected for a swimming system like this, so I used flying instead. Copy the following nodes. Make a new variable for the fluid simulation reference. Set instance editable and expose on spawn to true so we can set it directly. Make sure you set the variable type to the BP fluid sim. You can alternatively set it from the blueprint by getting actor of class and choosing the fluid sim. There should realistically be one fluid simulation in the level, so it will only work in that case. If there are multiple, then you will have to write logic to select the correct one. Get the fluid simulation reference and apply fluid force impulse. This will create a water ripple and will be used to add one when the player enters. Copy the following values. Since this is experimental, it is highly recommended to not use this in a final game as of now, but if you want to, you should very thoroughly test the values and how it looks in game, as it also works differently based on the scalability settings. This swim horizontal variable is used to store the initial rotation when the player enters the water. Next we will spawn the buoyancy actor and make sure to set the player reference variable to self. For the location, get the buoyancy scene's world location. Set the return value to the swim buoyancy actor variable we made earlier. We will now add the timer that will be used while swimming. This is an alternative to having to use the event tick, which is performance heavy as it runs every tick even if not swimming. In the event, add a sequence and first set swim mode. Add a select node and copy the following conditions. Now we can very easily keep track of and access the current swim mode using the enum values we used, which we can very quickly and easily understand. Otherwise we will need to keep adding branch conditions every time we want to know the current mode, and it won't be as readable either. Next, call the set XY position event from the buoyancy actor. In then 1 and 2, call the swimming buoyancy and exit swim trace functions. Remember, you can change the input values if you want. For then 4, call the toggle underwater ambience event. The input should be if the swim mode is not treading. This is since when treading the player's ears are out of water, so it shouldn't be heard. Then add a branch that checks if the current velocity is greater than a certain value. I will promote the value to a variable called max swim velocity and set its default value to 500. This value will require testing to find the best. If true, we will set the velocity to the current one clamp between 0 and the max velocity. This ensures the player can't swim above a certain speed. You may want to remove this if you want to add different features, however, such as diving or underwater currents, but that will require different logic to make it work with the current flying deceleration setup. I will now comment the events. Next, go to the swim actor, enter check blueprint. We will fill in the unentered water now. It will simply call the start swimming event from the player variable. Make a new function called get input direction and copy the code. This function will return the input direction relative to the camera and the input keys. Go to the movement input code. At the end of it, add a branch that checks if swimming, and if true, then set the roll value of swim horizontal to the actor rotations roll. yaw should be the get input directions yaw. Make sure to set it to a pure function. This will allow us to rotate the player in the water based on the input keys and camera direction, which basically simulates orient rotation to movement. Then make a float variable called swim vertical and set it to the following value. The swim pitch rotation amount should be how much the player rotates while descending or ascending. Then add the descend-ascend input. Check if it is greater than 0. If true, check if the buoyancy is in water body. If true, then add movement input. This ensures that you can only ascend if underwater. Connect the initial false straight to the movement input. For the world direction, get an up vector of the control rotation using only the yaw axis. The scale value should be the action value, and since we added the negate modifier, pressing Q will give a scale value of -1 while E will give 1. Then set swim vertical to a float interp with the following setup. This will smoothly set it so it doesn't snap the player rotation. Next we will do the end swimming event. Add a sequence and clear the swimming timer handle if valid. In then 1, set the movement mode back to walking. Then reset the other variables. Destroy the swim buoyancy actor if it is valid. The valid checks aren't 100% necessary since they are being spawned only when swimming anyway, but it is just an extra precaution for bug prevention. Then add a small delay before toggling the water enter check to false. You can change the delay value if you want the player to be able to exit and enter quicker. Finally, fade out the underwater ambience if it is valid. It will automatically destroy it once the fade ends. We will now do the sprint event. Make a new input event for it. Add it to the input mapping context and set its control to something like left shift. Add the input event in the character blueprint. On started, check if swimming, and if true, set the max fly speed to the sprint swim speed. I set it up incorrectly here but fixed it later. On completed, set it to the swim speed. Next make a new function called swimming rotation with a float input called interp speed of default value 10. Add a local rotator variable called target rotation. In then 0, add a switch on swim mode. Copy the setup. This sets the rotation to be different based on the current swim mode. If underwater, then the player is rotated in pitch 2 based on if they descended or ascended. In then 1, set the actor rotation to a rotator interp with the target being the target rotation local variable. This is to smoothly rotate the player. You can change the interp speed input if you want to control the speed where a lower value will be slower blending. In the event graph, add the event tick. Call the swimming rotation function if swimming. Event tick, as I mentioned earlier, is not the best performance-wise, so you can call the function in the timer too, but I found that it was a bit buggy when called in the timer. You can use different methods if you want to avoid tick entirely, such as using a timeline. I will now test it. You can see there are some immediate errors. Parts of it are working, such as sound effects and the moving. We will fix these errors soon. First we want to set the deceleration so the player doesn't flow too much after movement input is released. You can set it to the same value as the swim speed dynamically if you want to. The enter water volume was also too loud, so you can reduce it. We will now work on the animations. Make a new blueprint class and select type anim notify in the drop-down for it. This will be the water interaction notify. Add an override function for the received notify, which will run when that notify occurs in an animation. Get the owner of the mesh component and call the add water interaction event. Promote the inputs to variables and set them to instance editable so that the value can be set in the animations. Set the default value of size multiplier to 1. Bone is where the effect should spawn and size multiplier is for different effect sizes. Now open the treading water animation. Find the point in the animation where you want bubble particles to spawn and add the notify we made. Since treading is with lighter force, I will reduce the size multiplier to 0.5. These values can be adjusted to your liking. I will add a second one for the feed. Repeat this for all the other animations, making sure to position them and set the inputs accordingly. You can skip ahead if you want to the time shown. I will now make the bubble particles. You can use your own particle if you have, but I found that translucent materials with lower opacity for realistic bubbles did not work properly underwater and their visibility was really weird, so I decided to instead make opaque bubbles in blue color so it looks a bit like they are underwater. Set the blend mode to masked. Copy the following nodes. This is a simple material which uses a radial gradient to form a circle, and a Fresnel is used to make the center a different color which you can control easily using the two vector 3s. Next, make a new Niagara system and select the fountain template. This will be for the feed bubbles. First click the material icon and change it to the bubble 1. Then change the loop behavior to once in emitter state so it only spawns once. Go to initialize particle and change the sprite size min and max to something like 3 and 6 so it is smaller. In shape location, change the sphere radius to 0.2 so it doesn't have that much spread. In add velocity, change the cone angle and inner cone angle as well to control the spread amount. For the velocity min and max speed, make two user exposed float parameters and drag them onto it to set them as it. Reduce the gravity forces Z value to -25 so it doesn't drop down as much since it is in the water. We need to make the particle move to the side instead of downwards as well. Select the add velocity component and change the cone axis to 1, -90, 0. Duplicate the particle for the hand bubbles and just change the sprite size min and max to a lower one. You can alternatively use one particle for both and make the min and max a parameter, then control it with new variables in the notify. In the character blueprint, add the even add water interaction function. Copy the following nodes for it. If you are not using the Unreal Engine standard rig, then use your own bone names here. This makes the particle faster if sprinting. Here, you should change the value of A to 0.5, which I forgot to do since if treading, the particles should be slower. Finally, add a branch with the following condition to play the swim splash sound if swimming on the surface only. If you have a proper animation for it, the hands notify should go when the arms go through the water. Now we will finally set up the animation blueprint. Open yours. If you are using the third-person template, open the Mani one since Quinn is just a child class of it. Get the swim variables function from the character and promote swimming and swim mode to variables. Make a new float variable called swim speed normalized. Copy the following nodes for it. This normalizes it between 0 and 0.5 or 0 and 1 based on if sprint swimming or not. Now go to the anim graph. Add a blend poses by Boole for the locomotion pose. If swimming, create a copy of the locomotion graph and rename it to swimming locomotion. Open it and delete the walk-run state. Rename idle and replace it to use a blend poses by swim mode. Right-click on it to add the extra pins needed for it. I did this slightly wrong, so we'll speed the video up and come back later to show the correct one. For the blend poses by Boole, change the blend times to something like 0.4 so there is a smoother transition from entering and exiting swimming. In the anim graph, Add another condition for the foot IK control rig which checks if not swimming since we don't want foot IK enabled while swimming. We are still getting that initial dropping error, but most of the swimming functionality is now working. You can see that the bubbles are staying for far too long, so need to fix that as well. First, I will increase the camera boom's target arm length so it is further away from the player. Now I will fix that initial dropping error. The error was caused since I duplicated the buoyancy actor for the swim actor enter check, which meant simulate physics was enabled. We don't want to simulate physics on this, however, as it should stay relative to the player. Uncheck the simulate physics option. Also, when you spawn it, you can reduce the scale to 0.2 so it is easier to visualize when testing. Now the player is not dropping while on land and correctly starts swimming when you enter the water. I set up the connections for the enter water sound incorrectly, which is why it was so loud before. The absolute velocity should go into value, not out range, so I will just shift the values. For the underwater ambience, I forgot to set the attach to component as the mesh. The swim sound, I used the start time here by accident instead of pitch multiplier. Now swimming is working and there are no errors when I exit play mode. I will now fix the particles. Open it and in emitter state, reduce the loop duration to something like 0.4. Make sure to change it for both particles if you are using two. I will also adjust the size multiplier in treading quickly. The bubbles look a lot better now. I will add some stairs to test the entering ripple effect. Since it went really fast, it might have been hard to see, but it was there. You can control the intensity based on the velocity by adjusting the map range clamp values. Again, as mentioned, since the water plugin is still experimental, it won't always work exactly as expected, so a lot of trial and error will be required to find values that work properly for you. Here you can see the ripple was larger and noticeable. Also, in exit swimming, make sure you set the orient rotation back to movement to true. I also went back and fixed the sprint error which I mentioned by swapping the values. Sprinting is working now. A strong ripple spawned there even though we just entered normally. Exiting the water works smoothly too. Now go back to the swimming state in the animation blueprint. Currently there was a noticeable transition when switching between the states. This is since here we used each blend space twice, so if going from surface swimming to treading, it will switch to the start of the blend space. To fix this we need to use only one instance of each blend space. So delete the blend by swim mode and use a blend by bool instead with the following setup. The transitions will be smooth and properly blended now. The last fix is in the movement input. First add a custom event to the descend-ascend code called setSwimVerticalSmooth and connect it at the end. Call it after setting swim horizontal here. Then make the following changes so the value is smoothly set using interpolation. That is all for this video. You can purchase this project from the link in the description if you want. The project files will include an exclusive leaning feature as well as the realistic island example made for the series. If you enjoyed, like and subscribe for more content. Thanks for watching.